Alright everyone, just give me 1 second. I just realized that I haven't got my camera hooked up, so I will be back in a second. Weird start to the stream, but hang on. Okay, camera is set up. It wasn't plugged into my computer, but that's okay. Well, welcome everyone. So, today we are going to take a look at making our two devices talk to each other. So we've got our iPhone app we're going to build. It's going to be very basic. Just probably a simple UI that's got just a readout that updates anytime the data on the ESP32 updates. And I've just been playing around a little bit this morning. So something I failed to mention last time when we were going through this, the IDE for the Arduino IDE for these embedded systems. There is, if you just wanted to play around, there is a section up here if you go File and Examples, and anytime you download like a new device, like a new, we go back into settings. Anytime you set up a URL for like new board types and things like that, generally they'll come with like a couple of good examples. So if in our case, we've got underneath examples, we've got like these are all built in, as you can see at the top. If you can read that, built-in examples. So these come with the IDE, and then down here you've got all these examples for ESP32 dev module, which is the one I've got selected at the top there, right? And so under here we can, like, these are very like straightforward basic pieces of code. So you can set them up to be a HTTP client. Like you could run a web server on one of these microcontrollers. There is some Wi-Fi stuff, how to set up Wi-Fi. There's a couple of Bluetooth ones as well. So you got ESP32 BLE Arduino, and then in here we've got like you can set these devices up to be like a beacon. You can scan other Bluetooth devices in the area. There's a good couple of things here. Notify is probably the one we're going to look at because we want to get some data and just continuously notify in a loop to anything that's listening that something has changed. And so I was thinking maybe we do the hall sensor, and that's like just about every chip has one of these built in. So it would be on the ESP32 itself, on the chip itself, and these can detect magnetic fields, right? And so what I've got here, you can see down, so this is all the code that you need, right? It's got the setup code. We set up the serial so that we can read information from it when we've got it connected. And then inside the loop, all we're doing is reading, like this is a built-in function, right? They give us this for free. You go hall read and the output will be whatever the hall effect sensor is picking up, right? And then we just print it to the console. And so down here, you can see this big stream of numbers. And if I grab a set of magnets, okay, I know I'm kind of in. I'll move it out of the way, even though you can still see. I'll move myself out of the way just a little bit for a second, so we can see these values. Yes, there's a little graph. I'll show you that in a second. So I've got the device, and if I put some magnets near it, you should see the value change. Yeah, so that's positive values. And if I flip it around the other way, we should get negative values. Yeah, how cool is that, right? So this can detect like magnetic fields. These are used, what are these used for? I think I've seen them used in things like switches. Like if you want something to turn on when a piece of metal goes past, because I think this should react to some metal as well. It should, I think it does. Does it? Yeah, it's got to be a magnet. So what I've seen in some systems is like you'll have like maybe something is rotating and you want to count how many times something has come around. So you'll drop a magnet on it, and as it comes past, it'll do a bit of a spike. You can see that in the readings. And so you can use these values like in your code. What you can do is you can go like if value is larger than, I don't know, 200, run some code, right? Or if it's less than negative 200 or above negative, whatever you want to do, you can run code based on like how close a magnet is or how strong a magnetic field is, right? Just sitting. Thing is, it's quite interesting how it behaves. Like, do a little bit of experimentation if you're playing around with this, because when the magnets, like, you would expect it to make a much, like, I can feel the magnet interacting with the metal on the case here. It's like there's a bit of, you have to get pretty close for it to have any noticeable effect on the readout, right? Can you see that? Let me move myself closer. We can have them side by side. Oh, we're going this way, are we? All right. Pretty cool. Go the other way. It's more noticeable when you got those negative numbers showing up. But yeah, if I touch it to the board off to the side, not much happens. Wiggle it around a bit, you kind of get a couple of weird readings. But yeah, it's like it needs to be pretty close to be picked up, it seems. But anyway, now I did break out a breadboard because I was going to do some, like, turn lights on and off and stuff, or have the app send a signal to the device to turn a light on or off. But I think that's going to be for another stream, because this one's going to be, I think, maybe fairly long to begin with anyway. Just reading information like the Hall effect sensor from the device, because we've got to do a lot of Bluetooth peripheral setup in the iOS app. A lot of boilerplate to start with, and then maybe we do a part 4 where we can send data from the app to the device. So at the moment, we're going to be reading information that this will be broadcasting on the app, and then maybe in a future one we'll go, oh, let's send information to the device. Yeah. And so I don't know if you've noticed, but in some other examples here, we actually have some pretty cool stuff. So another one that I just want to point out to you real quick is where is it? Must be under Bluetooth. Is it the Bluetooth? No, under ESP32. Camera. So there's a camera web server you can set up. So I remember last time I was talking about how you can get these that have like a ribbon connector on them, and you can connect like a small camera up to it. That's what you would use this example for. And you should be able to just like load that up, install it onto your device, and then it should just work, which is kind of cool. We'll see how we go with, I don't know if we'll get around to using this. If you want to know, this is one I just picked up off Amazon, I think, Elugu. They come in packs of 3. These ones are okay. I have been told that they're not great, but I haven't had a problem with them yet with this particular brand, but fine for me. They can be really expensive. I think you can get them, I think they can cost like up to $20, but usually you get them for like 3 or 4. If you want to pick up some breadboards, I suggest you do, because just as a little bit of an example. This device here is a bit wide to put on a single board. Let's see if I can show you here. Because it goes all the way to the edge and you won't be able to put any other components and stuff in there. So the way I use this particular board is I put two together and then I bridge the gap between them like that. And that goes in just like that. Okay. In future, I would love to use my Pico board, Pico dev board that has everything on it. And I've got a 10 DOF sensor. So it's got 10 degrees of, is it freedom? 10 degrees of 10 degrees of movement. So that'll be really fun to play with in the future stream. I haven't had a chance to have a go at that yet. So anyway, what we are doing today, right? So let's get into it. So over here, I'll just show you the graph real quick because it's probably just sitting there going, and you're just looking at it going, oh, I want to see what that graph's all about. It'll be great. I don't know if there's a way to crunch up these values because it's only showing like, it looks like it's probably less than a second of information. But if we bring the magnets close, you're not going to notice much difference in the graph, in the spikiness of the graph, but you will see the values on the left change, right? So just like the scale of the graph will be different. So just pay attention to the values on the left. You see how they jump up? If I'm quick enough, you can kind of catch the jump up, yeah? And then it kind of like settles back to being all jumbly if I stay still. Yeah, if I go the other way, we get negative values. Yeah, if you just move slightly, just a little bit, it gets all these little. So you can see how, like, if you had a rotating wheel with a magnet on it, you can get these on-off style signals, right? Like this could be used as a switch. You can count like how fast something is going, right? You could use it as a odometer or something. If you had a big wheel that was like a meter and you can measure how fast something's going, meters per second or something. Yeah, pretty cool. And then you can stream that to your phone, right? So that's kind of what we're doing today. Okay, let me get set up. I've already got a project ready to go in Xcode. Let me close this. And to open that, all you need to do is go Tools, and then you pop open Serial Plotter, much like how we went Serial Monitor. Where is my Xcode now? Over here. So I've called it Bluetooth Reader App, and all I have done is just started a new project, and I will make this code available. Yeah. And we'll go through and fix this up in a second. So the first thing I really wanted to do was go through and start writing some code for our module. Okay, and we're going to upload that. And all we want it to do is just send this whole effect. So this whole read information, this just needs to be submitted, like notified, pushed out to all the Bluetooth devices that are listening. That's all we want to do. And the code to do that is pretty simple. It's close to what we were doing the other day, right? And if you're not sure what that is, or you want to start from scratch again, go back to the other video and watch that one first. Okay, so we get rid of this. And what we can do is we can borrow some code from, so this is from our last stream. So we can borrow some of this code if we want, or what we can do is we can close this down. And this is the BLE notify code that they give us. And what we're going to do is we're going to go through and write this out again, just so that we can all follow along and see how it all works. Okay. So let me just move some windows around. Wish I could make the font smaller on this other screen, but anyway. So a couple of things we need to start with, right, to get this working. We need the Bluetooth modules. the Bluetooth libraries, I guess. So we need to set those up first. Just move this a bit closer. Okay, so to do this, we have to do an include, which is similar to an import in Swift. Actually, this syntax is very close to what we used to have to do in Objective-C. Now, all this Bluetooth stuff should already be downloaded. Like these libraries should already be part of, like when you download, when you connect to the ESP32 repository to get the list of all the devices that it supports. All this should be part of it. I think some of them, the BLE device stuff might actually be part of the Arduino IDE. So all this stuff you get already. You need BLE server. You need the BLE utils, and you need BLE 2902.h. Now, I think this is a library for the Bluetooth itself. So like there might be different types of Bluetooth modules. Now, I'm not 100% sure about that, but I think that's what that might be for. So first off, we start out with our server. So again, this code down here, I'm using this. This is from the Hall effect. What's it called again? Example. And we're piggybacking off that. We're going to write all Bluetooth code for it, and then we're going to grab those readings and then send it across Bluetooth. Okay, so up here we need to create a new server, and we got p server. All right, we'll set that to null because during setup we'll set this up. During this the setup, which is only run once, right? When the device boots, setup is run once. Loop is run as many times as the device can do it, right? As fast as it can do it. And so if you've got a faster device, this loop will run much faster. If you're developing things for like games, you'll need to make sure that your frame rate and such isn't tied to the loop itself. Remember if you got like a really old game and you were to run it on a much newer computer, the game would run faster. I remember Command & Conquer was like that. And I think Warcraft as well. But we're not making games. You could make a game on this, but that's not what we're doing. So then if we go BLE characteristic. Now this is what our app will listen to, and it's what our hardware, our ESP32 is going to push the information over, right? So this is like an address. And we start with null again. So last stream we had these all set up, ready to go in the setup function. What we're trying to do is make these sort of more public so that we can access these values from inside the loop. That's why they're up here, outside of setup and not inside it. But we will set these up inside setup. So we want to go device connected. So we want to keep track of when our phone or our app is connected to this, because what we don't want to do is just keep publishing the readout if nothing is listening, right? That's a good way to drain the battery if you've got a battery connected. So we'll set this to false. And old device connected. We'll figure out what that's for in a minute. And then we've got uint 32t. So this is the value we're publishing. I don't think we need to do this because we've already got a value here. All right, so this is the one we're going to publish. So we'll just keep that as is. Let's just drop that down. And we don't want it to be a uint because that means it's an unsigned int. And an unsigned int can only be a positive number, right? So we want it to be just a regular int so we can go with the negative values, because as you saw before, when you put a magnet up to this, if it's negative or positive poles, it will be a negative or positive values. So let's create some UUIDs for our characteristics, and these are what we need. We need to copy these across to the device as well. But if we get our Bluetooth scanner app open, we can see what these values are anyway, and then we can listen to them on the app. So it's not super important that we remember what they are, right? You can put anything in here, right? We can just, that could be it. But I'll grab these values just so it looks more legit. I'll just actually copy and paste both the lines, right? So we've got our service UUID and we've got a characteristic UUID. Now remember, a service is like the folder that contains the characteristics, okay? So what we'll do is on the app, we'll do a search through for, you know, we'll connect to this we connect to this UUID, and then inside there, we need to connect to this one. So it's kind of like, think of these as like keys for a dictionary or something, right? And we can use this to get the value. Might be an easier way of imagining it. Okay, now of course we need some callbacks, right? So anytime something changes or we want to send an update through the Bluetooth, we need to do a bit of a callback here. So this is probably the most complex part of all the code we're going to be doing today. So this listens to when a device is connected or when it is disconnected. Okay, and then during these callbacks, we will update our device connected. Now, every device that connects has its own unique identifier, and that's how we can get whether the device is an old one or a new one we haven't seen yet. Okay. Now, the cool thing about the fact that each device has its own kind of like address, which is not a UUID, means that you can uniquely identify the apps connecting to your piece of hardware. So like, let's say you set up a weather station, right? And maybe one person in your household likes the readouts to be in Fahrenheit or something, and someone else likes it in degrees Celsius or whatever. You can output different values from this based on the UUID of the connected device. Obviously, you wouldn't really do that in practice. You just have the app. Like if it's on someone's phone, they can just set their preferences up in the app anyway. But that was just an example of like, you could have it behave differently depending on which device is connected. Okay. My server callbacks, and this is public. And we go, bring this open here. BLE server callbacks. Now these are functions that are supplied to us on the callback, which is on connect. Now we have to set up the callback, right? All we're doing is just defining what it does. Further down in the setup, we're going to have to apply this to our Bluetooth code. I have to tell it to, this is the callback we want to run when something happens. So here we just go device connected. It's true. Okay. Can I fix up? Yeah, that's a bit better. We'll do the same thing here, and we'll go on disconnect. Yeah, BLE server P server. Device connected. That's false. Yeah, so then inside this loop, we'll have some code that's like, if device is connected, do this. If it's not, do nothing, basically. Okay, so in here, we got our serial begin. Let's change this to 115200. And then down here, I'll change it as well so I don't forget. So it's 115200. If you forget to do that, like we said last time, you'll get an output that is just junk or nothing at all. You might get nothing coming out. Let's clean this up just a little bit. Keep scrolling down. Okay, we're ready for the setup. So we need to initialize our device. BLE device init, and we can give it a name. In here it's got ESP32, but maybe we want to call it something else like magnet sensor. Yeah, let's do that. Magnet sensor. Okay. And then we will initialize our server. So we go P server, BLE device, create server. This will run all our setup code. P server. Then we set our callbacks. My server callbacks. You know, there's a good chance that none of this code is going to work because I might have a typo or something in here. The Arduino IDE isn't perfect when it comes to you would be used to Xcode, how it kind of like compiles as you go and it'll throw up errors when you've done something incorrect. This you won't know until you've actually like built. You have to build it, compile it, and then it'll say, oh, you've got a typo here or something. And then my server callbacks. Then we create the service. Oh, another pointer. P service. P server. Create service. And here is where we grab our service UUID. All right, and then you can have I think you can have as many services set up as you like. We're going with just one. But like I said last time, you would create a service, and because they're kind of like folders in a way, you would use them to categorize the functionality, right? So this one is for the Hall effect, and or sensors. This service, maybe we could call this sensors service UUID, right? And if we've got a bunch of sensors hooked up to this, all the different sensors will be a separate characteristic underneath sensor service UUID. And then maybe we'll have another system, another service that encapsulates another bunch of other characteristics, which are maybe not sensors, right? They could be data outputs or some or whatever. It's an example. Hey Omar, how you doing? Glad you can join. All right, the next thing is we need to set up our characteristic, and this is what actually sends the information to our app, right? So characteristics, if I can get that spelling correct, P service, which is, where are we going? Oh, it's here, our P service. And then so we want to add a characteristic to that. Now, if you've got multiple characteristics, you can just keep stacking them here in the setup. Like I said, if you have different sensors connected, some dev boards actually come with like a whole bunch of them already on there. Like this one we're making use of the Hall effect, right? So I think that's the only sensor we have on this, and that's built into almost any microcontroller, just about. Some will have temperature sensors in them as well. I don't know if this one does. Maybe we can inspect that, and it might be more useful to have a temperature sensor. The thing is, though, when these are running, they generate a bit of heat on their own, so they're not excellent at being accurate to what the actual temperature is, right? They might be slightly warmer than the ambient air. I'm great. How about you? I'm pretty good. When I got up this morning, I was quite tired. I was like, oh, am I going to stream today? It's like, yeah, better. It was like, I didn't do it yesterday. My plan was to do it yesterday, but I was just so tired after working over the weekend. And so it's just, I've been very, very busy. Okay, so the first parameter here is the characteristic UUID. So we need to name it something, right? And this is the name we can give it. It doesn't have to be this, like I said. You could just have a regular string. You could say Hall effects sensor UUID. You could just put that text there. Makes it easier from the other end. but it also means that it may not be unique, right? So let's throw that characteristic UUID in there. The next parameters is like an array, or it's kind of like, so we got some pipes, right? We got some pipes we'll put in through here. I'll show you what I mean. It's kind of more like a dictionary, right? You pass through BLE characteristic, and then we want to set this up as property read. So these are values that are supplied to us. We can use these. This isn't something that I've just made up. And then we can put something else through, which would be, so we went through these last time. Hang on, let me just type this out. I can't talk and type at the same time. Characteristic. And we could do property right. There's a bunch here. The main ones we really need, I'll just copy this across because it's going to be far easier for me to the formatting is off and I don't really want to go through and fix it. So let's go just copy and paste. So we got our characteristic UUID. Property read, that allows other devices to read the contents of this characteristic. So that in our case, that will be the magnet reading from the hall sensor. Property write, that allows an external device to write content across this characteristic onto this characteristic. Notify is like a publisher, like, so you know with Swift UI, the combine and stuff, we've got like publishers. It's kind of like what this is, right? The notify. And the indicate, I'm not entirely sure, and I don't think probably won't even be using that, and we definitely won't be using write today. So we'll just clean it up and just like, you know, make it clear what this characteristic is designed for, right? In your own code, I'd probably rename these to, like, instead of P characteristic, call it whole sensor characteristic, and then just give, you know, each of your sensors better names than this. But we're going by like the demo code, the example code that they give us, so we're just going to continue like this. It means if I keep these the same as what I'm grabbing the code from, less bugs, right? Than trying to remember that, oh, I changed the name of that. Okay, so we've got property read, we've got property notify. And if we continue on, we will add a descriptor. So this is another part that's kind of important, right? We have, it looks like they drop a link in for us. We might not. I'll open it up. I think this is going to go to the same file. Yeah, so this is the same file that we talked about last time. All these different assigned numbers for different devices, right? So if you remember this from last time, we'll just quickly show you, right? I don't know. These are all like the characteristics, and it has UUIDs for each of them. You know, their values and stuff. So it's not something we're going to go through again today. Watch the other video for that. So anyway, let's drop in. I'll show you what I mean. P characteristic. Add a descriptor. BLE 29.2. You can see there's quite a bit of boilerplate when you're working with Bluetooth. Unfortunately, that's just sort of how it is, but it's not too many lines. I think all of this will be less than 100, hopefully. And then you just need to start the service, right? Call start on the service. And then we need to start advertising, right? So we need to create an advertiser object. P advertising. I think I've spelled that correctly. BLE device. Get advertising. So this is the initializer. And then we need to, so much advertising, add service UID. So you need to advertise the UUID for the service. If you do not do this, our app will not be able to see it. What have I done? Set scan response. You know, one thing I don't like about this particular IDE is that the keystrokes, I wonder if I can, oh, that's better. when the debugger's running, the keystrokes just like delay, they lag so hard. Yeah, that's way better. Set minimum preferred. So there is a little bit of weirdness with this value here. We've got a comment. Now, I am not an expert enough to know what this means, so I'm not going to try and guess. But good thing is you don't need to know everything to make this sort of stuff work, right? That's the whole point of this, is to show you that even someone like me who isn't a complete expert on ESP32s or, you know, embedded systems and stuff can actually get something up and running pretty quickly. So we want to write, yeah, look, we got code completion there. Print line, and then we're going to go waiting for a client connection to notify. Okay. So this just lets us know that all this code in here was run, and we can check, you know, when we connect our device to the serial, the debugger, we can get some feedback. So we know that something's, we will work out where things have been broken. Here we go. So now inside the loop, we go. We need to do a check. If device connected, I think they wrap them like that. I wonder if that's what we need to do. P characteristic, we set a value, and then we need to notify, right? Set value. And our value is this var here, right? So we kind of need to move this up. Oh, no, actually, let's not keep track. We don't need to keep changing this, do we? What we can do is we can just grab this and throw that in there and delete that. We can even remove this one further up where it was getting set. And then down here, let's remove that for now. And then what we want to do here, we've got whole read. Let's see if this works for us. If it doesn't, because we're making changes to the example code, we might run into a couple of problems. That's okay. Heuristic. Notify. So this sends out a signal to the connected device that the value has updated, right? So what you don't want to do on the, say on the iOS portion of it, you don't want to just keep reading from the Bluetooth device in a loop, right? And then maybe it'll read it much faster than this value can be updated. And then so you'll get like duplicate values, and you won't know from your iPhone whether it's just the same, like a duplicate reading, or if the values actually change, like it's a new one, it just hasn't updated. So it's important that you send out a notify anytime the value changes, so that the app can pick it up and always show a single value once rather than duplicating it. In the example code, it goes value plus plus. So this whole thing is designed to like keep counting up, but we're not doing that. all we're doing is reading from the whole sensor. Now, what we can do is add a delay, and we need to do this because Bluetooth isn't designed to send updates as quick as you're seeing them in the output earlier in the stream. So remember, like those numbers were streaming by really quickly. Bluetooth isn't designed for that. It can't update that quick, and what can happen is it can get bogged up and then just stop working completely. So you need to put a delay. So this does mean that we are probably going to miss a couple of readings. So we'll probably have to average them out a little bit on the device. You won't get like, if you're doing magnetic stuff, it's probably okay. Generally what we would do if we had like the wheel setup I was talking about before, where you want to like detect when a wheel comes past, but you don't want to miss when that happens, right? Because if you're doing a delay and a wheel comes past and it's like a delay for fractions of a second, you might miss that pickup as it comes around. So what you would want to do is inside the loop, always keep the loop running and then keep track of how many times it's been detected, but only send that value across to your app after a delay, right? So it's possible we might get the whole sensor might spike 3 times while we're waiting for a delay. So what we do is we keep a counter and we say, okay, we keep, every time it spikes, we keep a counter and we go 1, 2, 3, and then we send the number 3 across to our app. 1, 2, 3, and then send it across to the app, right? So you keep like, you bundle up everything you want to send across Bluetooth into like little buckets of data. And that's probably the most efficient way of doing any sort of Bluetooth stuff on your device, because if you were sending it like multiple times, if you were able to notify a connected app many times a second, 1,000 times, 100 times, whatever, you're going to drain the battery on your device if it's battery powered pretty quickly. So you kind of want to batch them together, batch together readings. And you can use the loop to do like, you can get exact timings. Like if you're worried about them all coming through, let's say you send them all through every 5 seconds or something. And you want to know the times during those 5 seconds, like the timestamps of each of those things. You can still collect timestamps and send them along with the data as well. And then you can graph it on your app correctly. But the big idea is that if you're doing lots of these updates very quickly, like you got motion sensors and you need that to be sort of real time, you can probably get away with doing this delay with the 3 and then just sending the information across. But if you need like, if things are happening to your device within fractions of a second, you want to get the tiniest micro movements, and you got like a really sensitive sensor on there. Batch them together. It won't be completely real time, but you get much more accurate readings. And I think that's how the audio works as well. So like you got Bluetooth headphones. The reason why the audio sounds like crap coming in when you've got the microphone turned on for them is because it can't do the two-way communication with the bandwidth that Bluetooth has. It's just not strong enough. We'd probably need like Bluetooth 10 or something to be able to get like high def audio coming through. And so it reduces the quality of your listening experience so that it can pick up some stuff for the microphone and send it through. And I believe that information needs to be batched as well, right? It's not coming through. You're listening to a track that's like 44,000 hertz or something. It's not sending information to your headphones 44,000 times a second. It's batching that stuff together. Okay. So we got our delay set up. For us, this is fine. We can mess around with that. I think 3, in my testing, I went as high as like 5 or 6 on some of the other products I've built, just to slow things down just a little bit more. It depends on your application, right? But 3's generally okay. So the other thing we need to do is give ourselves the delay and give the device time for a connection to occur when a device is connected, right? So we detect when it's disconnecting, right? Device connected and old device connected. Go delay. So this will give, like I said before, it'll give everything a chance to get ready. start advertising. So once something has connected, I believe the advertising stops. So we see in the setup function up here, the setup method, we've got setup, and then in here we're doing like a start advertising. I think once something is connected, when the devices realize that something is connected to it, I think it stops advertising because the connection is made. There's no reason to continue doing so. And that might also be the reason why, you know, when you connect, you get like a Bluetooth mouse and you connect it to your computer and you put it in Bluetooth pairing mode. That's kind of like what the advertising thing is, right? And then once it's connected, you notice that the device sort of like disappears from all the other devices. Yeah, so you go to your Bluetooth settings, you can see that your mouse is connected to this computer, but if you were to try and look it up on a different computer, it just wouldn't be there because it would stop its advertising. And because like when something disconnects, you want to put this back into Bluetooth pairing mode because we don't have a button on here that says, okay, I want to go to, like, you know how like most devices you hold in a button or something and it puts it in Bluetooth pairing mode. That's what the start advertising does. But since we don't have that on here, we need it to always advertise when it's plugged in if nothing's connected. It just has to continue advertising. So let's do a print here so we can see what's going on. And then old device connected. Device connected. Okay, so the next one. This is the last bit of our code. Okay, and then we're going to move over to the iOS portion. Okay. Now, if we want to, maybe we should grab this reading and print that out. Do we want to? Is that what we want to do? Do we want to print out that reading? Let's do a build first. Because there's going to be problems. I just know it. There's always problems. If this works first time, I'm going to be very surprised. No, of course not. Characteristic. Yeah, typo. See what I mean about these typos? Let's keep going. Compiling. Yes, that is correct. You know, the compiler knows that there's supposed to be something there. It's the only thing that will work. It should just add it for you. I understand why they don't, but you know, sometimes you might want it to break for whatever particular reason. What have I done? P characteristic. What have I done? Expected before P character. What have I done? Oh, here. Yeah, there's gonna be a few of these, I think. This isn't this isn't the sort of code that I spend most of my days writing. Could you imagine how bad this would have been back in the old days with you make a single mistake like this and you have to wait all night for something to compile? What do we got? I think it's still further back because this was copy pasted, so we know that works. Come on. Okay, set scan response, set value. This needs another value in there. There's a couple of issues. Excuse me. What we got? Come on. Takes so long. Oh, it looks like we do need... We might not be able to just pass through. Interesting. All right, hang on. Oh, okay, yeah. We're missing a semicolon there. Any others that I'm missing? Do another compile. Yeah, it looks like I can't pass through the whole read value directly. So what I'll need to do is probably set up. We might have to do a little Google for this to see what different ways of passing through values to this set value. Because I know you can do strings and stuff as well. We may set that up as a string. We'll see how we go. I just want to make sure I've got this correct. Ah, there we go. It's kind of like adding commas and stuff in JSON or a dictionary or something. So some programming languages like you are fine with you putting one on the end. Some of them are not. Okay, so this is like the last one. So invalid conversion from int to uint8 unsigned characters. So we want it to be signed though. So let me see what we have access to. Can we go to definition? Oh, yes, we can. Excellent. So in here, it looks like we've got set value, int data 32. So yeah, if you ever get into trouble or stuck, this is kind of like documentation in a way, sort of. So this is the one that the example was showing us. We've got a regular int here. We should be the size of it. Right. Okay. I'm not sure why this isn't working. uint8 size t. So this is the one that the example is making us use. So I think what we can do, can we come across here? Can we just drop this? Is that going to work for us? If this fails as well, I'll just look up another past project of... Yeah, okay. Let me just look up a past project I've been working on and see what I've done there. It is somewhere around here. Where is it? It's on my desktop somewhere. I might have to do an open recent. Let's see. Nope. Okay. Give me 1 second. Oh, I know where it is. It's on my other computer. Okay. Alrighty, so we've got a few examples. Let me find my source code. Shouldn't be too long. Oh man, don't update. Alright. There's a lot to get through here because I've also got sensors connected in this other project I'm searching through right now, and that uses like different pins and stuff, which we'll do on the next video, right? Like what we'll do next time is put this on a breadboard and then add another module and connect it with wires and stuff. And then that should round out, like that should bookend this entire sort of series of, you know, creating your own sort of devices, hooking up your own sensors. Let's keep going. Where are we? Callbacks. There's a lot of code in here. Where's our loop? Oh, it's not in this file. Oh, okay. That's not what I was after. So what is the output? We've got... So this other project I'm using transmits JSON over Bluetooth. That's kind of not what we wanted to do today. Although, it might be a pretty good... Might be good educationally to do that, because maybe that's something that you will want to do at some point, right? Okay, let me see if I can find... I think JSON encoding and stuff is available to us. So let's see how we go with that. Let me give this a go. I'll drop it in. If it doesn't work, we can always remove it, right? And that'd be kind of cool, because then you can send a host of information across at once. So if we go... Oh, where did it go? We can send a string. This is a tough one. Can't decide which direction we should go in today. This is what the code looks like. Let me just drop this down. Let's get rid of all this and we'll just go with one value. Let's get rid of all this too. We don't need that. This is basically sort of how it works. Let me pass through this output. Let's grab this. See if we can get this to compile. If it doesn't, then I might need to grab... There might be a JSON... I might have to bring in a JSON library. But let's see how we go with this. Let's just do a compile. I don't know if this is part of what we get for free with the Arduino IDE. We'll see. No, it's a library we've got to add. So that's easy enough to do. And so up at tools, we can go manage libraries, and then we can do a bit of a search here, right? So we can do JSON search. And there's a number of them here, I guess. Don't know which one we should use. Oh, any second now. Let me check the file structure of this other project and see if we've got... so let's see what libraries we've got loaded. Can't seem to figure this out. It's been quite a while since I've looked at this other project. Maybe we just move on from this and just see if we can get these numbers printed out. So let's go with let's do a little Google search, right? Maybe this one will help. It's kind of the same setup as what we've got. And then down here, yeah, so they want to send a sensor value as well. The number of set value signatures to hand over a sequence of bytes to the BLE server as defined in the class. So AU int 16T would work for an analog read. Interesting. Sorry about this, everyone. It's just sort of how it is. When I'll edit down these videos at some point next couple of weeks and shorten them up, get rid of all the waiting in between stuff, and then re-upload. Okay, so that wasn't a help. Let me drop these out. Remove all this here. Yeah, it's not coming through. Do another search. Keep going. This is pretty cool. This is the same site from last time when I needed help, remember? So this is kind of what we're going to do in the next video, right? We're going to hook up some external sensors, not just what we get on this board. And then there's wiring diagrams and stuff like that, which is pretty cool. So if we scroll down, we got the loop, device connected. We want to, so this is temperature, set value temp. So I guess doesn't help us with what we're trying to do. Let's keep going. I think I may have found something here. Got. All right, let me show you this code. So this is again similar to what we had before. We've in our code. So just about every project can be set up in a similar way. So we've got our service UUID, characteristics UUID. So this is an example of what I was talking about earlier with the Hall effect sensor, which uses the magnets. And so here's a speedometer, right? So you can use this, like I said, on a wheel with a magnet going around on it, right? And when the magnet comes close to your device, it will change values, and then you can say, okay, well, that's one rotation. So the way this is being set up is they've got a number. Yeah, so they're counting the numbers. They're not actually passing through the value. Oh, okay. Okay, I might need to just cast this, right? I need to cast it. Well, I'm not smart enough to work out what I'm supposed to do here with that value. So sending, I don't know why it's just like sending an integer across is just. Let's try this. This may not work as well. We might have to set this on something first, a variable, and then read from that. Something's happening. I feel like it's got further than it did last time, right? Oh, here we go. Done. Okay. It works. Okay, it's compiled. It's finished. Okay, so the next step is to test it, right? So let's put this in bootloader mode, right? So you hold boot and then press the other button briefly. And then we should have our module show up here. Yes, let's upload it. Got to recompile, do an installation. Let's bring up the output here and we'll see it right to the device. Okay, connecting, uploading. This can take a little bit longer now because we've got some Bluetooth libraries on there. Yep. Okay. So let's move me across over here. There's some space over there. Okay. So the next thing we need to do is unplug and then plug it back in. And then we will go to our tools and we will open up the monitor so we can read what's going on. And you see here it's got waiting for a client connection to notify. So that's the printout that we had before. So what we can do now is grab our Bluetooth scanning Bluetooth inspector. I'll bring this across. So this is active and advertising. If we start scanning, we should find our device on here somewhere. They jump around so much. There we go, magnet sensor. So that's the name we gave it when we initialized it. If we interrogate, so we're doing a connection, and you can see this readout here from connecting to the device. This doesn't seem right. These are throwing errors everywhere. Okay. That's not good. Oh, this isn't good. Let's try again. Let's unplug, plug it back in. We'll give it another go. Waiting for client to notify. Yeah, it's gone into like a weird. All right, let's have a little read of this and see what's going on. What have we got here? We've got register dump. Load prohibited. Exception was unhandled. Waiting for a client connection to notify. I wonder if that's because of this here. I haven't got this set up correctly, yeah? So let's do a... Because what we're doing here is we're trying to cast... Yeah, that's not going to work. I think we might have a problem. Let's comment that out. Let's do another upload and just see if that is what the issue is, right? So I've plugged it back in. I'm going to put it into boot loader mode again. Yep, and then we'll do a compile and we'll push it to the device. Come on. Unfortunately, this is kind of how it is, right? It's slower than iOS development, that's for sure. Compiling. Hard resetting. Okay, so let's unplug, plug it back in. Let's go to the serial monitor down here. Waiting for a client connection to notify. Nothing's happening yet. If we find our magnet sensor here, it looks like we've got some information now coming out. So this is the characteristic. If we got BEB, yeah, that's this one here. That's this value. So if you look over here, 688, there's the characteristic. We found it. And then this is the service UUID, which is this value here. Okay, so that's all coming through fine. When it makes the connection, it starts running this code, and it appears as though there's an issue with it. So we need to debug and work this out. I think the best approach is to probably, just to get something working, right? Let's go with let's do this. Let's add a value here. Read it, and then value. So this is copying the code that we had from the example as close as possible. Let's do a build and see if this works. Don't know if we can set whole read to this, but we'll see. No, it's going to give us problems with that. Oh no, hang on. Let's try again. Here we go. I don't know why I'm holding this up at the moment. Nothing's happening with it. We're just compiling right now. We're not writing to the device. This seems to have worked. Excellent. So let's put this on the device, put it in a bootloader mode, copy it across, recompile again. There might be a way to do this without recompiling over and over again, but it might be that when you build on the computer without any destination for it to go to, it compiles it differently than if you have a you're telling it to go to a certain destination. Let's go, come on. Uploading. All done. Unplug, plug back in, go to the serial monitor. Waiting for a client connection to notify. Okay, pop this open. Let's find it again, magnet sensor. There it is. Are we connected? Start. It's like it's having problems still again. I wonder if there's something wrong with this device. Because it just keeps rebooting itself. We might have an issue with this device. Let me get up and find another one. If I've got more somewhere. Oh, I don't know about that. Maybe. This has got some other code running on it. You can see that in the output here. That's funny, and I'm just about to override it. So we know it works, hopefully. Oh, you know what I should have done? Let's cancel that. How do we cancel? How do we stop? Let's unplug. What we'll do is we'll see if we can get some readings from this, from the Bluetooth, and then we'll know. And then we'll know if this one works. All right, we'll do it before we override it. So if we go to serial monitor, we've got, it's saying as a Fire Beetle because it's got Fire Beetle code running on it. It's not a Fire Beetle. Characteristics, fine. Now you can read. Okay, so let's jump over here and see what we got in our. Let's stop this. Start scanning. Let's see what we've got. Yeah, so because I interrogated everything that's nearby, we've got all these items have shown up now. So ESP32 Bluetooth device. Excellent. So if we open, can we see what's on here? Can we see what the values we've got? Come on. Might have to stop this. Scan the services on this device. Where are you? Where'd you go? See, they jump all over the place. It's kind of a bit annoying, this setup. Got nothing coming through yet. It might be very basic code on this thing. There's no way for me to see what code I have on this, by the way. Let's close this down and then try reopening it. Yeah. I found that sometimes I have to reopen these things. So it's not doing anything now. Start scanning. This software is a little bit unstable. Still quit. Let's reopen again. Okay. Now we want to grab the SP32 device. We want to interrogate this one only. See what we can get out of it. Hello, Bluetooth scanner. Yeah, this seems to be working okay. All right. Okay, so we know this device works. Let's try and get something uploaded to it. Put it in bootloader mode. Let's build this and send it across. This is a size value, by the way. This tells you how big the number is. It's possible this is incorrect. I need to set it to something larger. Okay, we are uploading. I wonder if it's possible that a delay is not long enough as well. Well, who'd have thought we'd get hung up on this for like 45 minutes? Serial monitor, waiting for client connection to notify. Let's do that again. Over here we have our, where is it? Start scanning. Can't see it anywhere. Jumping all over the place. It makes it difficult. Where is it? Magnet. Where is it? Can't see it. See ESP32 Bluetooth device. Cannot see. Can't see the name of this thing. I wonder if it's using the same. Oh, it might be. Let's just pause this and restart the app again. Start scanning. Yeah, okay, so this is still here, so I'm guessing it's probably cached, the name of it. If I do an interrogation, yeah, this one crashes as well. Oh, all right. Oh gosh. Let's try and change this to a string and just send a string through because I think we can get away with that, right? So we've got a definition. Let's drop this crap out of the way, unplug it. We've got set value, we've got string here, so let's do that. This is probably a very simple problem to solve. Anyone watching this in the future will just be like, you know, you can just do this. And I'm just having an issue with the typing system in this. That's all I'm having a problem with. So the value of a characteristic is a sequence of bytes. These bytes data then stored by the BLE server and made available to the BLE client that requests them. What the bytes represent is a private contract between the BLE server and the BLE client. Right. There is no buffer data type for holding arbitrary signatures. The bytes, however, convention holds. So what we need to do is create a standard string instance. We code the following. To have a uint16 stored in the string, we would do this. Oh, okay. Okay. All right, so let's go. Maybe this is my problem. Hope you find it educational watching me struggle like this. I am feeling a little bit defeated. I feel like this is turning into not so good stream. We haven't even got to the iOS portion yet, so it's going to be a little while, and I'm definitely going to have to chop this up. Oh man, I hate editing videos. It's just, it hurts. Okay, here we go. Plug this in. Same output. Waiting for client to notify. Pop open this. We will grab this again. I think we need to pause. Start scanning. Yeah, annoyingly, it doesn't let us like reinterrogate. What is it? No, it doesn't let us reinterrogate the device, so we have to close. Yeah, we got to close the app every single time. This is still the fastest way to test these things. Once we have our app up and running, it'll make things a lot easier. Here we go. Where is it? Magnet sensor. Okay, so now the name's updated. Interrogate. And we have it. We got it working. Okay, cool. So all it was, I was just missing this. Okay. I was just missing that. Just that. Just yeah, we'll cut all that out of the main video. Okay, so let's go into here and we can see we should be able to see a value. We've got G coming through. If we do a value history, okay, yeah. So what we need to do is what we got. Why is there a G? I think what we got coming through here is incorrect. It's picking up different incorrect data type. We've got D now, right? Let's do it. We've got a C value. We refresh. We've got an F value. We refresh. So we've got a J value. So what we need to do is change the readout here. How do we do that? I think what we need to do is there's got to be a setting somewhere where we can say, oh, this is in hex, this is in, it might be missing from this. It's quite possible. So if I connect to maybe this device and interrogate, let's see what Bluetooth stuff we've got here. We've got model number, so yeah, audio accelerator. So this is my HomePod that's connected, and you can click on these. You can view the values, which is kind of cool. But I'm trying to find. Yeah, so over here we've got number, hex, and the string. So what we wanted, we don't have that option on our other one. So if we go back to our magnet sensor, oh, it's popped up now. Okay, excellent. Is this right? Are we on the magnet sensor? If we do a refresh, what do we get? Reading is not permitted. Ah, yeah, okay. So if I select this characteristic, it's not letting us change. Like pick the. So we've just got F, I, N, D, at symbol, L. So it's trying to convert it to a string, like the stuff that we're sending through here. All right, this integer. I think it's enough for us to work with. So let's go with that. Let's try this out. So let's start building our app. Okay. I've got work to get to after this too, so we've got to get to our app. And to make this work, we need to create a Bluetooth service, right? So we'll create a new file. We'll call it Bluetooth service. CoreBluetooth. Alrighty. So let's go with this. We'll go with the class Bluetooth service NS object, because we've got we're dealing with some older APIs here, so we need NS object, and we're going to make this an observable object as well. And we'll make it a singleton for now. Oh, we probably don't need to actually. We're just going to have one view, so we don't need to worry about sharing stuff across different views and things like that. So first, we do need a central manager. So this is our CoreBluetooth central manager, and we will force unwrap this because we're going to set it up in the initializer. I'll talk about more what this is going to do for us in a minute. And then we need to keep a reference to our peripheral, and our peripheral is this thing. And we need to have a reference to it, otherwise iOS is just going to like drop it and forget it. So you'll write some code that will listen for different Bluetooth devices in the area. And then what will happen is you need to keep a reference to the ones that you've found, so you can, do stuff with them later. Let me zoom in just a little bit more. Get a better look. Yeah, that's good. That's good. Okay, and so we'll call this our, magnet peripheral. We'll just go hall sensor. And this will be peripheral, and that will be optional. So CoreBluetooth, the CB stands for CoreBluetooth, yeah? And so there is a little bit of setup we need to do. And then I think at some point what we'll do is we'll have like an enum to notify our view when a device is connected or not. So what we can do here, let's open up, let's create it. Let's create it in this file. Oh no, I've lost my mouse. Hang on a second. There we go. I've got a multi-monitor setup. So I've got like, if I move my mouse to the edge of the screen, it'll jump across to a totally different computer. And sometimes Mac OS gets a little confused and stops working. So we'll set the enum up here. So we'll go like connection status, and we'll go like, I don't know, connected, disconnected, Maybe we want to show some animations while it's doing a search, right? Looking for, we probably won't even see it. It'll be that quick. Usually the Bluetooth peripherals connect pretty quickly. Connecting. We'll set all this, like we'll show this in the UI when it's all happening so you can see it. And maybe probably an error state as well. We'll see how we go. And I think what would be really, really cool is if we have some colors here. So I'm just going to bring this in. Error red, connecting pink, searching pink, disconnected, connected. No, you know what? Let's go without, because just keep this code simple, right? I don't want to confuse anyone with any extra stuff that we don't need to have in there. So what we're going to do here is have like a published var, and we'll just say like peripheral status, and we'll just mark this as I don't know, connection status. We'll start with disconnected, I guess, because that will be the initial state, right? Initial state will be disconnected. And then we go private. Actually, no, we're not having a singleton, so we need to worry about that. So we just go inside out init. We will have super init because we got an NS object here. And then we go central manager. We need to initialize this, right? CB central manager. The delegate will be this file, and the queue, I'm just going to set to nil. Okay, that's all you need to do in the initializer. We write an extension for this, and we go Bluetooth service, and we need to go CB central manager delegate. And what I like to do is just like build and then have it yell at me. Saves me, and then I hit fix. Saves me from having to look up which ones of which functions I'm missing, you know, which required functions I'm missing. So in here we got central manager did update state. Okay, so in here it will anytime the state changes of the central manager, it will come through here, and then we can listen to those changes. So if central state is, so we got powered on, powered off, resetting. There's like only a couple of values here. So we say powered on. So when it's turned on, it's all booted up and it's ready to go. We want to scan for peripherals. So we need to do a scan, which is very similar to the app that I just showed you before, that Bluetooth app, the Bluetooth inspector app. And we need to write this function. So we go scan for peripherals. It all kind of makes sense, right? Like intuitively, how this would work, you would need Bluetooth and you need to do a search for Bluetooth devices. So we need to write some code for that. And what we can do is we'll start with, we're going to do override. Central manager, scan for peripherals. See, there is a little bit of a downside to Apple's Bluetooth APIs, is that they are quite dated at the moment. And so there's a lot of, it feels like unnecessary work you have to do to get things happen. Like lots of boilerplate code, right? With services, and then we need to define these services. So we've only got one service, which is already in this code. So remember, we set up a service here. This is our service UUID, and we want to scan for services, and this is the one we want to scan for. So let's copy this code, this UUID, and we can place it in here, right? So to make this work, we will create so I think these are strings. I think we can paste this directly in here, but let's make it let's call it whole sensor service. Put that in there. And then we can do this just to keep the code a little bit tidier. I think that works. What do we got? Scan for peripherals with What do we got here? We need to change this to let's get rid of that. What do we do? CB core Bluetooth UID. That's what we need to do. We need to initialize this with that, which is core Bluetooth UID, and it will be a string. Yeah, I thought this was a type alias to string, but it's not. That's okay. Extra argument with, yeah, so this needs to be with services. Goodness. All right, so I think I got that sorted correctly, I hope. Yes, if we do a build, that should be fine. Cool, we get it compiling just great. And I guess we need to set the status when we're doing a scan, right? So let's set our peripheral status to, we'll say searching. Probably makes more sense to call it scanning, right? Scanning. Instead of searching, scanning. Okay, so scan for peripherals. This will run, scan for peripherals. Now what we need to do is make use of the delegate method on Central Manager, which is triggered when it finds every time it finds another service, right? So, and it's only going to trigger when it finds the service we have set up in here, right? So it's not going to do it for everything that's around me. We can set it up so that it can do that, much like this app, which does search for everything in my vicinity. But we're not doing that. We only care about the one device, which has this particular UUID on it, right? So it's kind of like it's like a loop, right? It'll be looping over everything in the area, and then when it finds a peripheral with this service, it'll say, oh, that's the one we want. We want to connect to that one, right? So what we got to do now, when it, oh, what are we doing? We go, yeah, this is did discover. So down here in our extension, we can just start typing did discover, and we get Central Manager did discover advertisement data RSSI, right? So we can make use, this is the delegate method I was talking about. Now, this RSSI value is kind of like how strong the signal is. And I think it's goes from 0 to negative 100 to 0. I believe that's the way it works. And so what you can do with this is you can say, like, if the device isn't within a certain strength of the signal, don't connect. So like if you think that at a certain distance it's going to be, you're not going to be able to get a constant stable stream of data, you just be like, well, no, the app will say, hey, I found it. You could put up your dialog box in the app that says like, hey, I found the device, but the signal is really weak. Bring it closer, please. Which is kind of cool. We won't be using that. We'll just, I'm sitting right next to it, so the strength should be pretty good. And then what we can do is we can do a print and say like, I don't know, discovered, what do we got? Peripheral name. And then we need to set it here, which is optional value. Oh, let's just can we force unwrap that? Yeah, cool. If it crashes, we'll know why. And then we want to set this peripheral. So we've got whole sensor peripheral up here. We're just waiting. It's an optional. We're just waiting to set it. So as soon as we found one, we go whole sensor peripheral equals peripheral. And we know it's fine to do this. We don't need to do any other checks. because we've got this hall sensor service, right? So we're not just setting any Bluetooth device we find to hall sensor peripheral. We're only setting the one for the services that we're listening to. So if you have, thing is, if you have like 10 of these laying around with all the same code on it and you plug them all in at once, our app will connect to whichever the first one it picks up. This does mean that for like future projects, if you're building a product, you need to do some sort of like some secure stuff with it, right? So you don't want it like, so let's say you build an amazing product. It's this little Bluetooth device and you know, it takes the world by storm. Everyone's got one. You don't want to use the same IDs for each of them because anyone with the app can connect to anyone else's other device. So you have some sort of security protocol going on there as well. Much like how you don't have, you know, like a car keys where you have a button on it to unlock your car. You don't want it to be able to unlock other people's cars as well, or other people to be able to unlock your car with their key. So it's kind of the same setup. So this is fine now for our experimenting and all that sort of stuff. It doesn't matter. I don't care who connects to this and reads the values from it. My neighbors can do that if they like. But yeah, in future, when you're building an actual product, you want to put a little bit of security around it. Okay, so we've set all that up. Now that we've made a reference, we can connect to it. Okay, so the connection code, central manager, connect, or you can just go directly to peripheral. You would assume that calling connect on central manager will hold a reference to this peripheral, but it does not. Let's see what we got here. Doesn't say. Yeah, interesting. It doesn't say that it doesn't hold. So there's no strong reference here from what I remember. So if you leave out this code, if this was commented out and you try to do a connect, it won't be available to connect. It drops away. It disappears. So you need to keep a reference to it. It's probably makes more sense to do it this way. Okay. Now we can, because it's an optional, yeah, okay, we'll do it this way. So the next step is to run some code when a connection occurs, right? So what we're doing is this is going to attempt to connect. It doesn't mean it's going to guarantee the connection. Okay, so what we need to do is let's set our status, peripheral status, to connecting, and then we need to use another delegate method that gets called by the central manager when a connection has finished, right? So did connect. And then we're probably going to need another one for did disconnect, right? Central manager did disconnect. And of course there's did fail to connect. So there's a lot to handle here, right? Did fail to connect. What I'm going to do is just do a print. I'm not going to worry about, so what I'll do is maybe I'll set the status and we'll just leave it at that because we're just experimenting at the moment, right? If there should be an error. Man, I hate these warnings. No error. There we go. Did disconnect. So this can happen for a number of reasons. So this could happen if you turn the device off, right? I think if you call disconnect on the central manager, this will get called as well. And also if you were to like move the device out of range, right, it'll drop and disconnect. So what we'll do here is peripheral status disconnected. You probably also want to do something down here after you've handled the error as well. Like say peripheral status sets to error, and then maybe it'll change after a few seconds to disconnected. the disconnected state, so it puts it back to its neutral state. But you want to be able to catch that error and do something with it. Okay, so in here is the important section, right? So we've got what we got? We go peripheral status connected. Yay! This is when everything works well, right? And then so what we'll do is we need to now we've got the device connected. We've got our the correct device with the services. Now we need to inspect the device for the characteristics that are available to us. So this is like another scan, right? So you scan all the devices in the area, and then you scan the device itself when you've connected to it. So peripheral delegate. We want to do a peripheral manager type. Let's see. Let's set it to self. Yeah, we'll do. You'd split this up, right? So you wouldn't have like the peripheral delegate on. You could. A lot of people do, right, on the Bluetooth service. But for me personally, I would move all the peripheral stuff to another file. But we're not doing that today. We'll set that up in a second. And then we're telling it to discover this services. So we found one with particular services available, and now we need to discover the services on the device, which we just use the exact same UUIDs we did before. And then I think once we're done there, we can say central manager stop scan, because we're kind of done at this point. And then here we need to do another extension on our Bluetooth surface. And this will be the CB peripheral delegate. And again, I'll do a build and then have it. Okay, obviously there's no required. Doesn't look like there's any required delegate methods. So what we can do is go find those. So on there, we've got one, I guess this is pretty obvious, did discover services. So in order to trigger this, we need to run our discover services code. And so when they are discovered, it will notify its delegate. In this case, it is the Bluetooth service, this file that we're in now. And it comes through here, and we've got our did discover services. So when our peripheral discovers services, we'll get notified down here inside this delegate method. For service in peripheral services. Okay, so you've got an array of services. It could be nil. For every service, we need to check to see if our characteristic is in there. Okay, so our characteristic is the Hall sensor. That's the one we've set up in our code here. This characteristic, this is the UUID we're looking for. Okay, and like I said, each service can have a number of characteristics associated with it. In our case, our device only has one service and one characteristic in that service. But you might get devices that have multiple services, which is why you pass through an array here for our whole service. And then you will have, once it comes through, you discover all these services. If you've set up an array, you might have many in this array here, many different services. So of course you want to loop through them and find the data that you're looking for, right? In this app, you can see that if you grab, I better not connect to that just in case it drops, right? So let's check out our HomePod. We've got what we got here. We've got services, and then we've got yeah, so it looks like we've got like two, it keeps jumping around. We've got like two services on there, and then each of those services have different characteristics associated with them. So you can kind of explore that with that Bluetooth app. So as we loop through these, we want to find the service that has our characteristic on it. Unfortunately, you can't just go like peripheral services and then characteristic, as if it was like a dictionary or something. That would sort of make more sense to be able to do it that way, but you can't. I'm sure you can probably write a wrapper around an array if the array, you know, has you could probably set something like this up if you really wanted to, if you're doing this a lot. But in our case, we're just going to loop through them. It's safer to loop through them rather than just assume that the services we get back is just going to have the exact one we're looking for. This is, you just loop through them. Okay, so as we do that, we go if we need to check to make sure if our service UUID is equal to Hall sensor service peripheral. That's our UUID there. So make sure that we've got the correct one. Okay, so that works fine. So we need to check that we've got that particular service. Not necessary because we know we've only going to have one. It's going to be the only one coming through, but we're going to do a check anyway. So you can apply this to your own code later if you've got multiple services. And then what we need to do is say peripheral, discover characteristics, and then we pass through our service, CB service. So this is the only way I know of to get a CB service to pass in through this discover characteristics, right? So basically you can't come up here and just start discovering characteristics immediately. You can't just go peripheral, discover characteristics and bypass discover services. You have to do discover services, get the service back in an array, and then pass that through to discover characteristics. And obviously what you could do is comment out this if you're not looking for a particular one. If you want to like print all the services to the console, you would like not look for a particular one in the array, and you just like loop over all the services, and then you discover all characteristics for all the services. Okay, so let's undo that. We only care about this one. So I don't want to distract you. Love your vids. Can you make a tutorial demonstrating custom push notifications? Yes. Custom push notifications. What do you mean by custom push notifications? Are you thinking like from a server, right? You want to set this. You can test notifications in. I know you said you don't want to distract me, but that's okay. It's only take a second. You can test notifications by grabbing like there's like a notification JSON file you can create that if you drag it from your desktop or whatever folder you've got it in to the simulator, it will create a push notification for you on the simulator. But if you want to do it from like a remote server, that is definitely a different video. Push. I'll just write this down. So maybe what we could do is, I don't know, find one that already does it, like how will we do this? We could create our own server that does it. Like for example, if you got a follower, the push notification would need to know the follower's username and send you a speak message. Oh, based on the action. Got it. Yeah. Okay, so there's a number of ways we could do this. So what we could do is we could create our own server. Maybe we do a little bit of Vapor code, set up a push notification thing from that. But there's a lot of like server setup and backend, and it's just anytime we go to touch backend stuff, it takes the video from like a 10-minute job to something that's like a 3-hour course or something. So maybe we'll use something like Firebase, some other service. There is a desktop app you can get to that someone's created, some open source thing that creates a push notification server on your computer. So maybe we can do something like that instead. Run it directly from the computer, and what will happen is the device will listen to you push notifications coming from your computer. So yeah, maybe we do that. I'm looking into using a server with Firebase Cloud Function Fs. Okay, so maybe Firebase would be the way to go. But to give you like a quick overview of that, yeah, it's just like a JSON file that comes through. There's a few values you need to put in there which are required. I can't remember what they are. It's been a while since I've done it. But you'll have like 1 or 2 required values, and then there's one that's called like payload, I think it's called. It's just a dictionary, right? And then inside the payload, you can set the values you want to send. And then when that comes into your app, in the old days, we did it through the app delegate. It would just listen. But in Swift UI, it's going to be different, right? So maybe I'll have to go and learn how to do that. And then I'll show you on the stream, and then chop it up and make it into a video or something. But yeah, when that push notification comes through, your app gets notified, and then you can just inspect the JSON that has come through and use it. So we'll continue on. Peripheral did discover characteristics. Here we need to do our characteristics. So let's just jump back over to our characteristic UUID. I'll grab this, go back to our app code, and we'll just drop it under here, right? So we'll go whole sensor characteristic. It'd be kind of nice if UUID, if these were a little bit different, so that don't get confused with them, right? So like maybe this is a characteristic type UUID, just different type safety stuff I'm thinking about here, so that I don't accidentally pass this through to the services or something. That's okay. So we'll pass through an array of these, which is whole sensor characteristic for service. Excellent. Now I'm not sure on the documentation of this. If we pass through nothing, does it discover all of them? If the characteristic UUID's parameter is nil, this method returns all of the service's characteristics. So I assumed as much, because I was wondering like how do you find them if you don't know what they are? If you don't know what the characteristics for a device are, you're kind of helpless there, right? This is much slower than providing an array of characteristic UUIDs to search for. When the peripheral discovers one or more characteristics of the specified service, it calls the peripheral did discover characteristics for error function. So we're going to implement that one next, which is another delegate method. After the peripheral discovers the service's characteristics, you can access them through the service's characteristics property. Great. So if we send through like a nil array here, it'll just scan all the characteristics there. So ultimately, like what you could do is, let's say you could build an app very similar to this one. That scans all the devices in the area, scans all their services, and then scans all their characteristics and prints them out or displays them onto the UI. So you could do that after following along here. No Bluetooth device necessary. You could re-implement this code yourself and create a Bluetooth scanning app. Pretty cool. Okay, so what function did it say? It was peripheral did discover characteristics. So let's do that. Did discover characteristic. Excellent. For the service, let's just make that a little bit. All right, so of course we have our peripheral now, and it should have it'll be on the service, yeah. So for characteristic, we're going to do the same thing again, another loop in service characteristics. So what's kind of funny is this object here, this services, the services in this array don't have characteristics on them yet, I don't think. So that's why we have to do so now that obviously it's the exact same type, but now they're populated with characteristics, apparently, I guess. That's what I mean. Like, it's kind of like dated API. They should clean this up a little bit. Like it would be nice if they could just bundle all into one function, right? Like all you care about are the characteristics. You don't care about the services. Or you could just like the one function says find characteristics. You give it an array of characteristics on services. Give it an array of services or something similar. You could abstract that yourself, I guess, write your own wrappers around it. But I don't know. I just feel like if Apple did it, it'd be much more efficient. Set notify value. Is this what we want? Yes. True for characteristic. Okay, set notify value. When you enable notifications for the characteristics value, the peripheral calls peripheral did update notification state for method of its delegate object to indicate that the action succeeded. If successful, the peripheral then calls did update value for method of its delegate object whenever the characteristic value changes. So what we're doing here is setting up the listener for the changes that happen on this. So anytime this sends out, remember that code before we had this set value, right? And then we have notify. This notify is connected to property notify. We set up the characteristic so that it can notify. This is its abilities. We're giving it abilities here. It can read and it can notify. So whenever this is run, our app listens to this and then grabs the value, right? So this, anytime this runs, our app will grab the value. If, like I mentioned before, if this was commented out, we would need the app to request the value every now and then. Like you would have to set a timer in the app and say, I want to request the new update every second. This way, the app gets a notification, and it's like not a push notification, but it gets a notification to say, hey, the value on the Bluetooth device has changed. This is what it is. And that's what we're doing here. And then of course, because of this, we got another delegate method, right? When the value updates. And of course, they only give us like one, and then we have to determine which value it was that updated, right? So you could get notifications for many different characteristics. You need to sort through them all as they come in and work out which one you're listening for. In our case, it's just the one, but we're going to treat it as if there's more, right? So here we go. We go did update value for characteristic. Oh, now we want to get the characteristic that we're listening for. So if characteristic UUID is equal to whole sensor characteristic. Like I said, if you have multiple characteristics come through, you would need to do the same here. You'd have to go like if characteristic.UUID is equal to, I don't know, temp sensor characteristic. Right, you'll have to do it for all of them. For all of them. Any other ones you're working with here. Okay. And what we need is to grab the value. So we could go, yeah, let's do it this way because the data could be nil. So we have a data object here. You can see that it's value data. It's optional. And we'll exit early, yeah. But let's do a little print so we can say no data received for, yeah, so this way characteristic UUID string. We don't have the name of the characteristic, so we have to do the UID. To make it easy on yourself, maybe you'll make this an object. Characteristic object, so maybe you could do like struct characteristic, and then you have like let UID cb UID let name, right? And then you just create them this way, so this value, these values will be here, and then the name, and then that way you can print out the name for debug reasons, or maybe you want to show a name of it in the UI, not this. Yeah. You could do the same. These could be enums as well, and you could put a variable like a computed variable on an enum. So you can switch on. You could switch on these, and then like we had earlier, If you saw earlier, I had different colors for the statuses, which I removed. But yeah, there's a number of different ways you can do this. I'm just going to print out the UID. We'll know what it is when we see it. Good chance none of this is going to work immediately, so we'll have to do some debugging, so it's good that we're printing out a couple of things. And because we have a data object, we need to do catch because we only use the JSON decoder on it, right? So let, what do we call this? Let sensor data, well, are we going to use the JSON? We might need to go back to our device and pass through JSON. Can we do it this way? Can I, from decoder, can we do, I wonder, if we can just go straight from the value from, ooh, this is going to be, see what I can do here. Because I know we can just convert this to a string, right? Let me do a little bit of a Google search here. Can we do it? I don't think I've done this before. We've got an NS data, right? Because I want to change, I want to get the integer value out of it, right? Okay, so data, let's go Swift data to int. Let's see what we get. How to convert data to int in Swift. Let's see if we do it directly. I don't want to have to go back to our device code and then go through the whole thing with JSON and stuff. So one can use with unsafe bytes to get the pointer and load the integer. First convert your data into a string like below and then use that string to initialize it. I guess. I guess we could do it that way. No, everyone else is like converted to a string first. Oh, come on. There's got to be a... yeah, let's give this a go. Let's give this a go. I want to try and avoid that if I can. Yeah, let's do it that way. So we might not need to do a do catch here then after all. Okay, so, and then I'm gonna do a print. Okay, let's do a print. The data is this here. Okay, we got a build happening. All right, so what I need to do now is call this code. Let's just double check, make sure everything's all good, right? So on init, we are setting up the central manager and we are listening for when it is powered on, which will happen after this has been initialized. Once power's on, we start scanning for peripherals. So all we need to do is just initialize this class somewhere, right? So if we go to our content view and we create a state object, and we'll call this the Bluetooth manager. Oh, we'll just call it Bluetooth service, yeah? Let's just call it service, keep it short. I don't know if it'll work through the previews, but let's find out. It won't because we're not getting access to the debugger through this, so we need to. we need to make this run on the simulator. All right, come on. Let me just move this to the side. I'll pop open console so we can have a look. Should get something coming out. Okay, here we go. What we got? Bluetooth reader. Looking for configuration, no name. Oh, no UIC configuration dictionary. Okay, so because we're using Bluetooth, we might need to permissions and stuff. And I might need to run this on a device as well. Connection invalid. All right. So I think what we need to do is go here and we need to set up capabilities. Do we have to do Bluetooth? We might not need to. There is a system where, you know how sometimes you get like the pop-up when you use an app and it's like, it's asking you to connect to different, it wants to know what devices are around you and that sort of stuff. So let me just Google this. Because I think this is what it's telling us, right, to do. Yeah, it looks like we've got purple links here. So this is stuff that I've searched before. Sync configuration. Oh, this was for a different issue. No, this is for a different issue. This isn't the same thing. This is because the way that this project's been set up. Okay, so what I need to do is info plist Bluetooth permissions. Go. Okay, if you're not using Bluetooth, just add this to info. Bluetooth always usage description. Our app does not request this permission or utilize this functionality, but it is included in our and it's Bluetooth always usage description. Since we don't have to add anything. Yeah, privacy Bluetooth always usage description. Hello. All right, let's do a run through again and see what we get. XPC connection invalid. I'm going to run this on my phone really quick. You won't be able to see this, but you'll be able to see the output. Let's see if this makes a difference. Launching Bluetooth reader is oh yeah, that's what we want. Okay, so I have on my phone. Oh my gosh. I got notifications coming through, so I'm gonna block them. See that pop up? I was move my face. See that pop up? That's the alert that we just created then in the info plist. Okay, so I'm gonna hit OK so we can allow. What I need to do is trying to work out why I'm not getting any logs at all from my Bluetooth service. So we've got init. We've got. Okay, so what I'm probably going to do is do this powered on thing. I'm going to do a print in here. CoreBluetooth powered on. I'll do a run and see how we go. Okay, it's powered on. Scan for peripherals up here. Scan for peripherals with services. And then, so this code here is not running. All right, let's do this again. I'm gonna try and get this working on the simulator so we can see what's going on, right? Pop this open. Yeah, it doesn't seem to be working. It looks like we got to do it on device because I was getting hitting breakpoints. I was hitting these breakpoints on my phone just then. So let's run through this. Okay, scan for peripherals. Great. That's kind of what we're after. And then nothing. It's not discovering any of these. This is pretty sure this is still on. Unless it's still connected this thing to my computer. So let's unplug, plug it back in. It should be, yep, waiting for client connection and notify. Let's run the app again. I don't have a UI set up where I can hit scan to start scanning. And nothing is coming through. So we're not hitting, it's not discovering any of our peripherals. Okay. But at least the scanning has started. So it might be a setting in the app that we need to change. So let's take a look at that. Give me 1 second. Let me see if I've got signing capabilities. I've got another app here I can look at that I've done all this work in before. Nothing in signing capabilities. We've got... Okay, I wonder if I've missed something in the code, right? I can't show you this code, unfortunately. But kind of useless to you anyway, it's a bit messy. So I did discover peripherals. That's not being run at all. Let's do a little Google. Do you have any Bluetooth devices nearby? Yes. Okay, so what we could do is pass through nil for this and just see, we'll just see if things are working, right? So if I close this off. Also, I've got groceries showing up soon, so I might have to, they might actually be here now. I might have to run off for a couple of minutes. Okay, so that's working. And the code does work. So it's just not finding any with our Hall sensor service in the area, right? So we have a peripheral that's found. If I drop down here, it's supposed to print the name of it. Because we're force unwrapping, and this peripheral that we found, whatever it may be that's around me right now, does not have a name set. And so it's crashing because of that. That's okay. So we know that our code works, at least. It is getting into did discover peripheral section. It's just having trouble finding our Bluetooth device with that advertised service, which is interesting because this should be working. The other app we had was able to pick this up. So let's go see what we get out of this. No name. Let's see what we get. Let's do another run. And we'll cycle through these one at a time. That might be interesting. Powered on. Let's drop this away. We know that works. Oh, we got to set this to nil. Okay, here we go. It's discovered. Look, there's a name there. Magnet sensor. It found it. This is kind of weird, right? It found our sensor, but not when we set the service ID. There might be something up with that. It might just, you know what? It might be the fact that we got lowercase values here and we're doing a comparison. Like maybe they all need to be uppercase. I don't know. We'll work that out. I don't know if they're case sensitive, but it looks like we found it, and it's going to try and keep connecting. Yeah, so you can see here, name, magnet sensor, state connecting. Did you forget to keep a reference to it? So canceling connection for unused peripheral. And what we've got here, we do have it set up. we are keeping a reference to it. So there's a little bit of funniness happening here too. So what we're going to do, I've got to work out what the problem is here with this services, right? So let's try and go uppercase. See if this makes a difference. Still nothing. Service UUIDs and the services UID parameter. When you do, the central manager returns only peripherals that advertise the services you specify. If the service UUIDs parameter is nil, yes. The recommended practice is to populate the service UUIDs parameter rather than leaving it nil. If the central manager is actively scanning with one set of parameters and it receives another set to scan, the new parameters override the previous set. Interesting. Okay, running into a little problem here. We've got an array of CB UID objects that the app is interested in. Each represents UID of service that peripheral advertisers. So we got this set correctly. I don't think I've made any changes to these UUIDs. So if we, like for example, let's say we set this to nil, right? And then when we get into the did discover peripheral, instead of printing out the name, let's also print out the let's see if we get anything out of this. No name. No name, no name. No UUID, that might help. What we got here? So we found my MacBook. There's no UUID. Yeah, because the services are empty, I guess. And that's okay. So let's drop that away. This is really interesting, isn't it? Because we haven't got... We're running into a problem with this functionality. So I've got some other code. Let's just have a look through. I have abstracted it a little bit. Scan for peripherals with services. Interesting. When we do a check, when we do a match, we need to do uppercase. So when we do a comparison down here, we should probably do an uppercase because I think that's what they come through as. Or uppercase both of them. Because we're doing direct string or UUID comparison. UUID comparison should be fine. We shouldn't need to do that if If we're doing direct string comparisons, we would need to. I think we're okay with that. But yeah, it's super strange. We've got Hall sensor service with services. So I've got the service stuff set up correctly. We've got 4FA, we've got 14B. This is all good. Let's change this to nil. For each of these, we want to print. So we got my watch there as well. That's way up the other end of the apartment. No UUID, no name. We've only got like a couple here. Let me unplug and plug back in. Maybe that's our issue, right? Need to do a reset. Every time we connect, we might need to unplug and re-plug it back in. Yeah, so we've got quite a few more coming through here. So we've got no name. No name. Let's see if we've got our magnet sensor. And so if I... Interesting. Okay, so let's go. Let's do it this way. Let's go if peripheral name is equal to... Let's do it this way. There's always a workaround, right? We connect to it. How about that? And I'll just force unwrap that there. Now it's possible that this, so we got a content view here. We've got a state object that shouldn't get deallocated, but if it does, then the Bluetooth service gets deinitialized and then it has to be set up again. So that's why in my other project, I've got it set up as a singleton. So it's there for the lifetime of the app. And the reason, like the main reason for that is because we don't want to drop our references to our peripherals, because as soon as we do that, we lose the connection. Let's do another build, run through this. And then, so what we're doing now instead, yeah, we are connecting to, we're only connecting to the peripherals that have discovered, not the discovered, magnet sensor. They have magnet sensor in the name. Sorry, I just copy and pasted that output. Let's do another run through, so we get a little print. Discovered magnet sensor. There we go. And it looks like the connection is working because we're not getting those errors from before. So all I've done here is I am looping over every device we can, every device we can find. For some reason, when I provide it with a service, it's not working. So we're looping over all of them. We're finding them. We are connected to them. We are connected. The peripheral status will update for that. And we're now calling Hall sensor service. So, and it looks like we're not getting like an error or anything, but what we really need to do is we've got discover services down here. We need to do some printouts down here so that we know that something's happening, right? So let's do a little print. And if else, oh no, we won't worry about that. We'll go print. Found. We got Hall sensor peripheral. Hold up, this isn't correct either, is it? Why is that compiling? What have we got? What have we done here? So we've got connect to the peripheral. Yep. If service UUID, this is incorrect. Service UUID should be Hall sensor service. Found service for. So this is just for debugging. And then we go discover characteristics, notify value true. And we go print found characteristic waiting on values. Let's just go with that and see what we get. Right? It works. Oh my god. See, I thought, okay, this is the highlight of the video. we got it working, right? So the values are now coming through. What's so funny is that I didn't think this was going to work. Converting the data to an integer, right? And it appears to work. So if I grab a magnet, please do something different. Oh, look at that. Oh, I think we may crash if we try to go in the... What have we done? what have we done? I think we broke it. Wait. I think we broke it. But hey, it works. Kind of works. If I do a restart of this, did the device break or did the app break? I think the device broke. Oh no. Unplug. Plug back in. Restart the app. Okay, it's okay. It's fine. We didn't damage it too much. It seems like we may have overloaded the... So we'll put the magnet closed. The value is climbing up a little bit. If I reverse it, we have issues if we reverse it because, as you can see, this is maxing out the integer because we're using an unsigned int, right? So if we go negative values, it's going to... we can't have -1, -2. It has to go, instead of going into those negative values, it jumps back up to the maximum that the integer can be. And now it's stopped. I think what's happening is maybe the Bluetooth is getting clogged up. So like what we probably need to do, instead of have a delay of 3, we might need to set that to something like 5, right? That might be the problem. Don't know. But the idea is because, yeah, we're using an unsigned int. We've only got positive values. It has problems trying to do negative values. That's something we can fix later. But I think the main point now, what we need to do is build a UI to show these values. And this is going to be pretty easy to do, right? So right now we have the sensor data integer coming back through. We're doing a little print. That's great. But what we need is a property up here. So we'll say like published var, and we'll say, let's go with magnet value. How did I do that? A little diamond thing. Magnet value, and this will be an integer. And we'll set that to 0. And then down here, we'll just say sensor data. Yeah, we'll just go magnet value equals sensor data. Now I can set this directly, but I'm not going to do that. And we may, do some other stuff down here too, or add it to an array, and then we can present it in a graph. So next step, let's jump back to our content view. Refresh this. And then in here, we want to, show the value, right? So I guess one of the important things is that we want to set up the connection statuses. So if I say text and I say service, and then I go peripheral status, we don't have a raw value because we don't have a type. So let's make that a string. And we'll set this to raw value. Oh, I'm getting so hungry. I haven't had any breakfast. So there we go. We got disconnected. Let's see if we zoom in a little bit. Move this across. So you can see that we've got the disconnected state. So that's our default state. Let's make that a bit larger. Font title disconnected. And then underneath that, we'll put service. And we'll go magnet value. Because this is a number, let's wrap this up like this. There's our value there. And let's set this to, I don't know, large title, font weight, I don't know, heavy or something, right? Disconnected. Now, how am I going to show you this? Because the simulator... How are we going to do this? Oh, you know what's funny? Did you see that? Sidetrack. I'm basically breaking this device by like rubbing the magnet on all these points, which I shouldn't be doing. That's bad. Let's go reset again. Connect. Okay, I don't know how I'm gonna show you this on my phone. I'll try. So I'll build this for my phone. It's connected. Found characteristic, waiting on values. I will unplug. Let's go for camera. Open up Bluetooth reader. Let me turn on do not disturb. You can see the value here is connected. I hope that's not backwards. It is backwards. All right, hold up a sec. I think it's like, you know what it says, but I think it's important to still. Let me flip this around a bit. And plus, I'm on the other side of the screen now. It looks a bit weird for me facing the edge of the screen. So let's go flip horizontal. Okay. Oh, that's my dog. I'm gonna show my dog. Yeah. Anyway, so let's reopen this. So we got disconnected. Come on, focus. I have to do like I'm gonna have to set up a system where I can pass my device screen through to OBS. So I'm gonna disconnect the device. I'm gonna plug it in and see if we can watch this update for real. This is difficult to do with one hand, but I'm gonna try my best. Oh, come on. If I do it vertically. Plugged in. We might need to reboot. Oh, I don't have a button to set to reinitialize the Bluetooth. This is gonna be impossible. Okay, hang on. Okay, so we got disconnected. I'm gonna rebuild. Oh, you didn't get to see it update the connecting or from disconnected to this way. From disconnected to connecting to connected. You don't get to see that, but there's the values they're updating. Okay. Oh gosh. Now I'm gonna grab the magnet and put it near the device. Okay, wrong direction on the magnet. Yeah, let's do it that way. Now it's disconnected. So I think if I get too close with it or I'm touching, other pins and stuff, it disconnects and stops working. But you could see that if I unplug, plug it back in, oh my gosh, restart, rebuild the app. Go again. Connected. Let's put the magnet close. Got 3 digits. It updates really quick, so see, there you go. There's the max. That's the highest energy you can get. There we go. When you wrap around backwards. Okay, so look at that. Take away. Put it on. Take it away. Put it back on. Take it away. So this is kind of cool, right? We've loaded code onto a microcontroller with Bluetooth capabilities, and then we're sending information from that microcontroller to an app. Like, how cool is that? I don't know. I think it's pretty cool. The stuff you can do with it. Like, come on, think about it. You could make a you could make a Bluetooth keyboard, right? Like this is really like, this is something I put together before I got my Stream Deck, right? I was trying to be really cheap, and I thought, oh, I'll get a Pico Pi and make my own keyboard and 3D print all the parts. So like, even the keycaps are even the keycaps are 3D printed. And I've got some brown switches off another keyboard that I pulled apart. It even lights up, I think, but it needs to be plugged in. Let's keyboard setup assistant. No, quit. I don't know what this button does. I didn't stop the stream today. You see that? So what you could essentially do is throw a battery in here, and then not have a cable, and make your own little a Bluetooth version of the Stream Deck. And you could like control, open up an app on your phone, have this as a separate something to control your phone. I don't know, maybe a bit silly. I guess something else you could do is have the reverse of it. Like you could have an array of LEDs, and you could set different sequences of like light up sequences from your phone. So much like how these lights behind me are controlled by the Nanoleaf app, you could create your own Nanoleaf style app and control Bluetooth lights around your house, right? You could create a new product for it. You could I got one. So if you wanted custom, hold up a sec, making a mess here. So I like to play D&D and Pathfinder, things like that. Haven't been able to lately for a good while, but like there's like terrain, these still need to be painted. But what you could do is you could have an app that communicates with like Bluetooth devices embedded in these, and they could light up, make sounds, stuff like that, all from an app. And these are things like you can't really buy, right? You can't buy like an app controlled mountain for a landscape you're doing, right? This is stuff you have to build because it doesn't exist. And that's probably a good reason. There's probably not a market for that sort of stuff, but like the potential's there, right? A Bluetooth enabled plushie toy. So that's a cool idea. That's something I'd probably like to do at some point. Get a plushie, cut a hole in it, put some sounds in there, make it put a hidden camera. Just kidding, hidden camera. I don't know. There's not really any limits to that. Like as soon as you expand outside the iOS ecosystem, it's a massive jump. It's not like you can just do double the amount of things, right? As what you can do on an iOS device. You can do, I don't know, 100 times more things once you've sort of branched out a little bit. And you don't need a lot of equipment to get started. Like I said at the very first stream, like these things are like $3. You can pick these up for $3. You've already got an iPhone, probably, if you're here learning iOS development. You've already got a Mac. You don't need anything else. Yeah. A phone, a Mac with Xcode installed, Arduino IDE installed, and one of these, and you're set. Like all sorts of stuff. There are kits on Amazon you can get. I think they're like $80, 80 Australian dollars a kit, which comes with like a pack of sensors, right? So all sorts of different sensors in there. There'll be like motion, temperature, light, moisture sensors. So you can make one of these that are battery powered that sits outside in a little enclosure, and you can measure whether you need to water your garden or not from an app, right? You can talk back to the app. These are Wi-Fi enabled as well, so you don't have to even go through the process of setting up these Bluetooth services. That Bluetooth services are an option, but if you've got these set up to Wi-Fi, they can just connect to your home Wi-Fi network, right? And your app can just look them up like a regular server. So if you already know how to do your server programming, like if you've built a weather app before, right, that uses an external endpoint or something to download information, it's the exact same code that you just treat this as a remote server. If you're on Wi-Fi, you just hit its IP address, you know, and not mess with all the Bluetooth stuff. Maybe we'll do that in another future stream. But I think we got the point across mostly of how this works. I know there was a big gap today where I was struggling for about 30-45 minutes, trying to work out how to get the data across. It's still not perfect, right? Because we're not getting negative values at the moment. This is something I need to reevaluate off stream. I need to get this passed through as an int. I wonder if it's as simple as... It can't be, right? If not, it's fine. But I think we get the point across. Let's just see if we can do a build on this and see what happens. Be kind of cool if that works and we get those negative values showing up. Nah, it doesn't like that. That's okay. That's probably it from me for today, though, because we are well into almost 3 hours and I am very late for work. And my client, is probably stopped in every now and then, is watching the stream. I'm like, okay, when's Bo gonna be finished? Yes, I'm finished now if you're watching. I think that's about it really to show off. If you want to, like I said, if you want to try this on your own, all you need is ESP32 to follow along with this. The process is exactly the same if you have a Pi Pico. The new Pi Picos have Wi-Fi capabilities. I think they have Bluetooth as well. I think the chip has both of those on it. There are a bunch of others you can use as well, but those are probably the easiest to get. I suggest picking up a couple. Like if you're going to order it anyway and pay the delivery costs, because these things are so cheap, you may as well just get a bunch, because they cost less than the cost of delivery. So you just get a couple of them, and then that way if you blow them up, it's okay. And what we'll do next time is maybe we'll take a look at. I keep saying maybe, but we certainly will. I want to do a video like a follow-up to this, you know. The whole point of this is so that we finish up with everything you need to get started, and then, you know, every video after that sort of just adds on, right? There's the first 3 are the main ones. You have to watch them all, and then we'll just add on extra stuff. So this, we're going to chuck one of these on a breadboard, and then we're going to get... so this is for next time, right? Breaking stuff everywhere. So this is for next time. I do have one of these boards. So this is 6050 sensor. So this is, see that little chip in the middle there? Everything else around it is supporting for just that chip. These larger modules make it easy to work with than the single chip itself. But this is a sensor, so this will be motion. So X, Y, Z values we can. So what we'll do is I'll solder on some pins on this, and then we'll stick this on the board. We'll run some wires to some input pins from the ESP32 to this device. We'll plug it in. We might even, I don't know, see if I can get a battery hooked up to it somehow. We might upgrade ourselves to the Firebeetle ESP32 board because that can handle batteries quite well. And then we'll have I can walk around with this and move it without it being connected and stuff. And then we can get those readings on the app and we'll graph them. So Apple has given us in, I think, iOS 16 now, we've got a full on charts API. I've done videos on the charts before in the past, but what we'll do is the XY values that we get off the motion of this, we'll feed it straight into the app and then you'll be able to graph it, which would be kind of cool. So yeah, next topic is going to probably just cover hooking these up together, and we're not going to do any software for it because the streams get very long when we do that. So I'll go through things like clock signals and then sending writing the code in Arduino IDE for getting these two things to talk to each other, which is really simple. You just import a library for this, and all the libraries are going to be compatible with this, right? So the library just knows how to read the raw information of this and convert it into something that we can use as programmers. And then all you would do is take the information from that's the output of this, much like we took the output of the hall sensor, take the output from this, and we just send it across the Bluetooth. It's the same process. We've just added an extra little step. And the library will handle that for us, right? There's very minimal setup for the library. It's basically the same as hall read. It's as simple as that, right? It'll be like, read the XYZ data. That's kind of all it would be. So it's really simple. It's like Lego. They all just connect together and just work. It's not that complex. Don't be intimidated by electronics. I think programming in general, this stuff here, like in Arduino IDE, the programming side, making iOS apps is far more difficult than putting hardware components together in this way, like pre-built stuff. If you're designing these boards yourself, it's a little bit more complexity to it, but mostly it's just plugging things together. So thankfully we have standards, right? Universal standards for how things can talk to each other, which makes it so much easier. And then the point of this is that eventually you might like glue the sensor on top of the board, then glue a battery to that, and then you'll have like a little handheld module you can put in places, and maybe there's a microphone on it, or you make a little bug. I don't know. I remember as a kid that was something I wanted to do. Have like spy gear, but as an adult, it's kind of like, no, it's not as innocent as you think. It's a little bit creepy, a little bit weird. But as a kid, kids love that stuff. They're like, oh, listen to what my brother's doing or something. You don't think about how weird that stuff is when you're a kid. Anyway, I'm off. Thanks for joining me. This time I did remember to set up my little Patreon board, so I'm going to put that on here. Look at that. I've got a couple, but some of them wanted to remain private, so there's that option on my page if you wanted to subscribe. Eventually, when I get to enough users on this channel, I'll probably enable ads. I haven't decided yet, but I'm definitely not taking sponsorships. Unless it's something that I can fit into the content, right? So like if a fellow indie developer was like, hey, do you want to talk about an app that I built for developers? I'll be like, oh, if it's for developers, maybe I'll do that. But most of the time I'm not going to. I definitely don't want to pick up sponsorships because, there's people that pay YouTube Premium to not see ads, and I think it's a bit crappy when you're a customer of YouTube Premium and you're paying to not see ads, but you still see sponsorships in a video. That's not something I want to be part of. So I think if this becomes bigger, most of the support will come through Patreon, I would say. But yeah, that's and of course, like over there, just message me if you want to see anything in particular. I've written down some notes already. We want to do push notifications from services and stuff like that. That's the notes that I've written down for next videos. I also want to get out a video on Dynamic Island, and yeah. Anyway, thanks for joining.